So this is the heating curve. H2O is in its solid state, the temp is at its lowest, and therefore there's the smallest amount of kinetic energy because heat causes the H2O molecules to speed up and produce more kinetic energy. Also, since there is no phase change, the temperature is rising. In this part of the graph, a phase change is taking place on a plateau, which means that the temperature is not changing. The substance is going from a solid to a liquid through heat of fusion, when a substance is melting or freezing. 0 to 100 degrees Celsius, water is a liquid, and the temperature is rising. 100 degrees Celsius, there is another plateau, and therefore another phase change from liquid to gas. The substance undergoes heat evaporation, where it vaporizes into a gas. After 100 degrees Celsius, H2O is a gas and therefore has the most kinetic energy because the particles can move freely. Also, the temperature is still increasing. This is an endothermic reaction, meaning that heat is being added. In the solid state, the intermolecular forces in H2O are still intact. However, as more heat is being added, more energy is being added, which causes them to break apart. Water has strong intermolecular forces, H-bonds, which are not easily broken. This is why it takes so much for water to melt and boil. However, once H2O is a gas, the intermolecular forces are completely broken. This is the cooling curve. When water is above 100 degrees Celsius, it is a gas. In segment 2, there is a phase change from gas to liquid at 100 degrees Celsius. There's also a plateau, meaning that the temperature does not change, and it's going through heat of condensation, meaning that the gas is condensing into a liquid because heat is being taken away. Segment 3, between 100 and 0 degrees Celsius, water is decreasing in liquid form, so temperature is decreasing. Segment 4, there is a plateau and therefore a phase change from liquid to solid. Solidification is taking place, meaning that as heat is being removed, it is becoming a solid. In segment 5, there's the least amount of kinetic energy present. Intermolecular forces are completely intact, water is in solid form and decreasing. We do not know when that will stop. Once again, because this is cooling, it means that it's an exothermic reaction, meaning that heat is being removed. Another important distinction to make is that intramolecular forces are not affected by this because they are the forces that are holding the H2O molecule together. They are the covalent bonds. As you can see, as more heat is removed, intermolecular forces begin to repair and come together. Now, water is in liquid form, and then more heat is taken away. Intermolecular forces are further made, and now water is a solid. That's the end of the video.